With the release of the new iPhone, 5G just got real, apparently.
Today, with iPhone, the wait is over. 5G just got real.
At least that's what people are saying, and they're not wrong. Now tons of people have iPhones with 5G. But what does that mean? Like what can you do with a 5G phone? And what's up with all the speed tests? I mean, is all 5G the same? And what about Wi-Fi? Is it gonna replace Wi-Fi? That's what we're answering in today's video. 3 things you may not know about 5G. Now I got some help on this one. I got a chance to interview the VP of Network Engineering.
My name is Heidi Hemmer, and I'm the Vice President of Network Engineering for Verizon.
So this video has the potential to become very geeky. So network engineers, network admins, IT people, get ready. And TLDR, nothing. It's all about the network, and yes. Anyways, keep watching. Oh, and thanks to Verizon for sponsoring this video. Yeah, okay, keep going. Okay, number 1, you got a new 5G phone. Oh, wait. You got a new 5G phone. Now what? What can you do with this? Well, the answer is not much, which might sound harsh, but it's because we don't know what we can do with 5G yet. Now, let me back up for a second. You can still do everything you can on 4G, just faster. How fast? Well, it depends. Because often 5G might feel like this, even if you have that 5G symbol at the top of your phone. But why is that? Well, it's because we basically have 3 different flavors of 5G. Chocolate, vanilla, no, I'm just kidding. Low band, mid band, and high band. Or fast, faster, and insane. Not kidding about that one. Now, if I had to pick my favorite flavor, it'd be high band all day. But you can't always have your favorite flavor. Not all the time. If you have a 5G phone, you're probably using low band 5G. It's nationwide and it can go far. You can be far away from a radio tower. Really far! But your speeds might feel like this. Lower band frequencies are like marathon runners, man. They can go far, but they're not sprinting. They're not that fast. And you see 4G speeds because these are the same frequencies that 4G uses. But here we go. Things really start to cook, start to sizzle when we move up the bands. At mid-band, we're looking pretty good. Speeds that you might be used to, 100 megabits per second, all the way up to things you're probably not used to, 900 megabits per second. But the higher we go, the closer to the tower we have to be. So the closer we get, the faster the speed. Now I gotta be honest, I don't get too excited about mid-band or low-band. I mean, we already have these speeds with 4G. So what's new? Well, what's new is what's next, because here's where I start to pay attention. Here's where the caffeine in my veins start to boil. High band. Let's move up there. Now, to take advantage of high band frequencies, you do have to be closer. A lot closer. And this is where the speeds really start to feel like 5G. Like we're doing something crazy and new and unheard of. Yeah, you gotta be right up next to the cell tower to get these speeds, but we're talking speeds that are from like 1 gigabit per second up to possibly 10 gigabits per second. Now, what flavor of 5G you get just depends on where you are. Low band, nationwide, man, get that anywhere. All the major carriers are playing in that space. When you go higher up the spectrum, you have to be a bit closer to the radio towers. And then high band are going to be for our dense areas, our cities. This is where you hear about the cell towers being put on light posts and various other places throughout a city. Lots of them.
We started out the build in municipalities and in places like stadiums and arenas and airports, where we had access to city furniture, where we were able to easily and quickly install nodes, both antennas and radios on street lamps and traffic lights, etc. And obviously inside of arenas and airports, we're able to install up in the ceiling to provide that experience for our customers.
The main player in high band is Verizon with their 5G ultra wideband. Now they call it ultra wideband because they're going pretty high up in the frequency ranges, using frequencies that we've never really used before for consumers, for phones and businesses and stuff. That's why we're seeing speeds that are face melting. But you do need a bunch of small cell radio towers. And that's what Verizon's done. They've been building this out. Look at their map here. All these flashing beacons are areas you can actually take advantage of the ultra wideband. I'm actually here in Dallas, so I'm excited to try that. Now I want you to keep this in mind. You don't have to worry about what band you're gonna be on. Your phone and your carrier will auto-magically select the best type of network to be on. If you're in a big city with ultra wideband, guess what you're gonna be on? Ultra wideband. If you're walking through a cornfield in Nebraska, you might just be on 4G.
With a Verizon device, wherever you are, if ultra wideband is available, you would lock onto that. If you move out of the ultra wideband millimeter wave coverage, you would lock onto our 5G nationwide network, that coverage layer. And if that's not available, then you would lock onto our lightning fast 4G network. So the device and the network are always talking to each other, and we'll put the customer on the best network experience possible at that given point in space and time.
So what can you do with your 5G phone? Well, if you're outside of a big city, But if you do venture into a big city that has 5G ultra wideband, man, run yourself a speed test. Melt your face off. And just know that we don't know what we can do yet. Now, number 2. not all 5G is the same. It's not all created equal. And I'm not just talking about low, mid, and high band. I'm talking about what happens after the cell tower. Now, I'm about to get geeky here. Network engineer geeky. So buckle your seatbelt, put your helmet on, get ready. Now, for the most part, when we think about 5G, we think about this right here. The connection between my phone and the radio tower, making that as fast as possible. But hold on a second. As a network engineer, I know that my internet traffic does not stop here. You see, once it reaches the radio tower, there's a whole other world, a whole other network. And I'm talking Ethernet and fiber cables, servers, routers, switches, firewalls. Now, I would love to assume that most carriers' networks are fast. But you know, they were built for 4G. 5G is going to bring a lot more traffic into a network. So is your carrier's network that was built for 4G, can it handle 5G traffic? I don't care how fast your 5G connection is. If this network sucks, your experience will suck. Now, honestly, I don't know about most carriers' networks because, you know, they didn't tell me. But I did ask Verizon and they did tell me.
Today, when you are on one of our 5G sites, there is a 4G anchor site that takes you back to the 4G core. And that's not unusual. And when we upgrade tech, that we work on that air interface first, because that's really where a lot of the magic is. Make sure, again, that we get that device to radio interface up and running and optimize, and then start to move back into the network to be able to upgrade the network. The 4G core works very well for us today, but in order to get the really low latency numbers that the promise of 5G brings, as well as network slicing, which I'll go a little more into, we really do need that standalone core.
Okay, so Verizon went out and built their 5G infrastructure, their radio towers, cell towers, all that stuff. And as of November 2020, the launching of this video, your 5G traffic does end up going to their 4G core, which, as Heidi says, it does work fine. It's been great for a long time. They have one of the fastest 4G networks, and it can definitely handle 5G traffic. But in order to truly deliver on what 5G promises, that super low latency, that crazy fast speed, you got to do something different. And that's what Verizon's doing. They're building this new network, which I'm so excited to talk about. They call it their 5G standalone core. This is a network completely, totally dedicated to 5G traffic. Ain't no 4G touching the stuff. Now this thing is lit. Heidi is about to tell you more about it. But before she does, the 4G network that I'm erasing right now is what you're currently using if you're using 5G, or 4G, obviously. And as Heidi is about to mention, it does have some of the features that we're about to talk about. They have added these improvements. But the big idea is for them to move to this new 5G standalone core, which hasn't happened yet. But when it does, whoo.
So we have been in the process of virtualizing the 4G core. And using that where it makes sense, moving into containerized design, right, and being able to have more software-defined networking there. But the 5G core will be completely built on that containerized design with the web-scale software architecture. It'll be all IP-based technology.
Man, I told you, 5G standalone core, lit. Now I want to talk about some of the things that Heidi mentioned here. First, SDN, or software-defined networking. Building and maintaining a network is a pretty big job. It normally involves entire teams of network engineers like me. And we're normally manually installing stuff, manually accessing each device individually. But that takes time, and it's slow. And that's where SDN comes in. SDN will use software to automate your network. So what would normally involve an entire team might just be me, using software to manage thousands of devices. And when you think about a network as big as Verizon, yeah, I think they need that.
So we like to say, we want to automate everything that you don't really need an engineer to do, so that then we can free that capacity, the engineer's capacity up, to do the really important feature functionality, customer experience work that we need.
So SDN helps Verizon deploy their network faster, make changes faster, adapt faster. And that plays right into the next two things, containerized and web-scale architecture. What the junk are those?
So in the standalone core, because we're going to software-defined network, we're able to use white boxes. And really where the magic comes in is the software that we put on top of that. We're also able to share network functions like compute and processing power, but then we are able to containerize the specifics that we need for a given customer and the use cases that they want to use. That makes for a more efficient core, and it also gives us greater service delivery timeframes, because instead of having to upgrade or apply a feature to the entire network, we're able to say for this particular customer, whether they're consumer or enterprise, this is a feature that they need, and we can simply put it in this container, this portion of the network to be able to do it, which means that we can spin it up much more quickly, and we can be assured that those resources that are being allocated are being used for that specific use case and customer.
When you see these two words, I want you to think cloud. Big cloud providers like Amazon and their AWS, Google and their Google Cloud or GCP. Containers and web scale architecture is exactly how Google and Amazon build and run their data centers, how they build and run their cloud. It's built for speed and agility. These companies have to be able to scale up their infrastructure when demand is high or scale down when it isn't. Put a network here, put a network there, take it away. That's what we're talking about. That's how Verizon's designing their new 5G standalone core. Now, there is a lot more that goes into those two words, containers and web scale architecture. I do have a video on containers right here, but everything else is a video for another time. Now, this stuff isn't new for Verizon. They've been doing this for a bit, actually, in their 4G core, ever since 2015. A crazy example of this already in the works is the situation this year. Verizon had to adapt to people being in cities, milling about, walking around, to a bunch of people just coming home and staying at home. That changed their traffic patterns like crazy. And according to this article on Mobile World Live, they were able to increase their capacity on different cell sites in hours rather than weeks or months.
It will help with service agility, so the ability to be able to give a certain feature functionality, product, etc., to our customers specifically customized for them very quickly. We'll be able to spin up and spin down capacity very quickly. So if we have a certain use case, you think about a Super Bowl or a concert or something where you have an great influx of people for a short amount of time. We don't want to build network capacity there that then is going to sit fallow for the next 11 months. And so moving over into software-defined networks will allow us to be able to quickly build the capacity needed for that event and then tear it down and be able to use that capacity elsewhere.
Now, something I was surprised to hear Heidi say is that this network has AI built into it, artificial intelligence or machine learning. Oh, so you said two buzzwords I wanted to pick up on, and I wasn't sure if this is what you're talking about. You said they're feeding the machine information to learn, and they're developing models, which that just spells to me AI, artificial intelligence. Is that a lot of what you're starting to use now in your network?
Yes, and so we are. That obviously is going to be an evolution over the next few years to continue to use that more and more. But we do want to make sure that we're defining the end state and what we want the network to look like and the experience for our customers, and that we're helping to teach those machines so that they will provide that end state that we require.
And this basically means that the network will automatically, intelligently configure things for you. Now, it won't take over and rule the world, but as you feed it information, as you teach the machine how you want your network to be, it will automatically apply that state. So for example, if a ton of people go to a certain area for a certain event, I don't know, normally there would be engineers monitoring that stuff and then making those changes, building up those changes, and I don't know how long that would take. But now with AI and machine learning, the network just sees that happening and it builds infrastructure. It scales up auto-magically. That's the type of network we need. That's really cool. And then one more bonus thing that I wasn't gonna mention, but I have to. That's MEC, or Mobile Edge Computing. I'll let Heidi tell you about this one.
Another element that we have announced is MEC, or Mobile Edge Compute. So that allows us to bring the compute right to very close to where it is required. And that's important because that really cuts down on the delay of sending a data packet from the node that's providing the air interface all the way back to the core and back again. So if you have this lightning fast air interface and a device that can handle it, but then you have to send the information miles and miles and miles back to the compute, that sort of undoes all the magic that you have in that air interface, right?
Right. Now for number 3, and I think this actually might happen. I think 5G will replace Wi-Fi. First, let me kick you a scenario. Imagine you're walking in a city and you got your amazing 5G ultra-wideband connection. You got this amazing connection, right? And then you walk into a coffee shop. Let's say you plan to do some work or whatever. Now, what's the first thing you do? You connect to their Wi-Fi because you want that speed and that reliability. But I think 5G will do away with that. Now, I'm saying this like I'm predicting. I don't know if it's going to happen or not. But here's what we can do right now.
We have just announced that we have partnered with both Corning and Samsung on in-building units that will allow us now to install within smaller areas like a local coffee shop, etc.
So in that same scenario, you walk into that coffee shop to do some work, you connect to nothing because you're already connected. You already have your connection. You already have amazing speed, probably even faster than you could ever get with that coffee shop, unless they have like some kind of fiber going on. So that's cool for an obvious reason. You just have an amazing fast connection wherever you go. And it's really cool for a second reason, and that's because it's safer.
That's very funny. Well, actually, one thing I haven't talked about in the difference between our networks and Wi-Fi, Chuck, is security. So that is another, especially, in an enterprise situation, but I know consumers are very concerned about security as well. And that is something that we provide that is materially different from anything you would have on Wi-Fi.
Public Wi-Fi, I don't know if you know this, is kind of dangerous. No, it's really dangerous. I made a video last year where I showed you how easy it is to hack someone on public Wi-Fi. This is a non-issue with 5G. All right. So that's Wi-Fi for public places, right? Okay, we can see that. But what about your house? And what about businesses? Will that replace Wi-Fi too? Yeah, I think so. Yeah, check this out. If you live in an area with access to 5G ultra-wideband, you may soon be able to have that in your home as your internet connection. And then for business, yeah, it can replace Wi-Fi. Verizon will actually sell what they call a network in a box, where you get your own private 5G core. And they give you the same equipment that they would deploy themselves. And you can deploy that in your company.
One of the other things that we are working on is having a network in a box that would be more like a private core for enterprise, where you could bring that in. You think about too, if you have a large multinational company, we could provide a certain experience within their domestic campuses that then we also could take into their international campuses, even though we don't have spectrum there. So we'd be able to provide a consistent experience to our enterprise customers, regardless of where they are in their office in the world.
Now I can see the comments already. Wi-Fi will never be replaced by 5G. And that is debatable, because Wi-Fi is constantly being improved and it's amazing with Wi-Fi 6 and everything. But I did ask Heidi why someone would go with 5G versus Wi-Fi in their business. And it's pretty interesting. 5G sounds cool. And a lot of the use cases we see, they're amazing. But in the back of my mind, and in a lot of people's minds I would imagine is, well, wouldn't Wi-Fi do the same thing in that situation? So for example, I think like a dense city and you're putting all these cell towers or small cell radios. Why not an access point? What's the difference?
So the biggest difference is that we own and control that spectrum. And so it is licensed and it is licensed to us. And so we can optimize that in a way that we would not be able to optimize Wi-Fi on access points. We also can very elegantly grow capacity. Not only have we built a ultra wideband that I just spoke of network, but we just recently launched our nationwide network as well. That provides 5G coverage. It's a coverage layer. Those speeds and the experience are much closer to a 4G experience today. But because we've put that 5G capable equipment out there, that will allow us, one, to share that low band spectrum across both 4G and 5G users so that we serve the customer base within that given area. As 5G devices grow and the penetration within our network, we can elegantly allocate spectrum to the 5G users without hurting the 4G users. And we're set for all the technical upgrades that are going to come. That will allow us to give an even better and better experience on that. With Wi-Fi, we wouldn't be able to do that. We have standards with the OEMs. We partner not only with the network infrastructure OEMs, but with the device OEMs as well. And we test the interaction between the two of them. In Wi-Fi, we wouldn't have that ability to have as much control over that interface or that interaction between the device and the network, and the ability to control and optimize the spectrum that we use.
Number 4. Now I know I said only 3, but this is bonus. Just consider it bonus. But it kind of touches on the first point, and that was, what can I do with my 5G phone? And the answer was, not really much right now. But my fourth point that you might not know about 5G is that it's really not about your phone. It's not about your speed test. It's a lot more than that. It really will revolutionize a lot of things. People are calling this the 4th industrial revolution.
It is the 4th industrial revolution.
And we're just now in the early stages. And Verizon recognized that, and I'll let Heidi tell us about how Verizon first started approaching 5G and what they did.
So when we first started talking about millimeter wave, there was a lot of noise in the industry about whether that was the right bet or not. There weren't any standards when we first started talking about it. And so we developed these technology forums, and we invited in our network OEMs, we invited in our device OEMs, but we also invited in application developers. Because we know that it's great to have a network, but if you don't have use cases for that network, or you don't have applications that ride on top of it, it's not exciting to customers. And so you can build this slamming, good lightning fast network, but if nobody has any reason to use it, it really doesn't matter. And so we spent 2 years, 3 years prior to actually launching, working with all these partners in an open lab. We have 5G labs, and folks can come in and worked on things like 360-degree view of people, so that you could try clothes on while you're sitting at home, right? You could upload a 3D photo of yourself and actually see what clothing on the web looks like on you. We worked with folks on AR, VR applications where you can be in a concert. We did this with the Chainsmokers, and folks that had a 5G device could hold it up and could see holograms on their device that other audience goers could not see just by looking on the stage, right? So
right now, 5G is kind of abstract. Like, yes, we can do all these amazing things, but I can't do it right now in my house. So we have to rely on examples. Like, okay, what are companies doing? How does that look like? How are they changing things? And one example I love involves network slicing, which will be a new feature, part of the 5G standalone core. But it's crazy what we can do. Check this out.
In a factory floor, our network may be running robotic arms, it may be running forklifts, it may also be running back office applications. And so if our network is running a forklift, we want to make sure that a spike in traffic on one of those other applications does not cause an issue with latency, speed, or throughput for the forklifts that would then end up in a forklift accident and perhaps an injury of one of the factory workers. And so we'd be able to, through network slicing, allocate capacity, speed, throughput, quality of service for those forklifts to make sure that they get what they need from the network to be able to consistently provide the feature, the functionality that we need them to do.
So this was 4 things you may not have known about 5G. Let me know in the comments below if you already knew these things, or let me know if you didn't. And if you know something I don't, well, also let me know. There's probably a lot, so let me know, please. Well, that's all I got. If you like this video, hit that like button. Speaking of AI and machine learning, it does tell YouTube. You teach the YouTube algorithm that you like my stuff and that everyone else should like it. So hit that like button. And if you want to see more of what I do, then subscribe. Hit that notification bell. Make sure you flip it over from personalized to all so you never miss an upload. Yep, that's about it. I'll catch you guys later.